Hi, this is Cross.Nabla in our second video for section 12.1, and we're just going to be going over planes and surfaces and how to graph the traces and the cylinders of these graphs in 3D, right? Before we start off, though, we have to go back to 2D, where a lot of our knowledge from pre-calculus or trigonometry or whatever class conic sections came up in will be very useful. And we'll just do a quick review of this. Be really expedited. Just use y instead. So this is just y equals x squared. And this is just x squared equals x equals y squared, like that. Ellipse looking something like this. These are kind of choppy drawings, but you get the idea. And for this one, for the hyperbolas, it's going to go out like this. Actually, that is a horrible drawing. Let me fix that for you guys. That's a more adequate drawing, even though it's not the best. And then like this, and then like this, and then you have your transverse lines going like this, transverse lines going like this, right? And that should be somewhat familiar for us. And going into surfaces in 3D space, we can use these traces or these attempts at traces from my very sloppy sketches of all these to graph these different surfaces. And we already know the plane from our previous video, and we know the sphere. The sphere is just an extension of a circle into 3D, right? That's not that hard to draw, and we can just draw them or attempt to draw it here. This is our plane, and then our circle, our sphere should look something like this, like that. And it's a eighth of a sphere, I guess. Actually, no, it's a fourth of a sphere. No, sorry, an eighth. Oh my gosh. Today is not my day. Wow. Anyways, let's go into example 1, sketching this. And if from our previous video, what we know about sketching these is just we do one trace and we do another trace, right? So looking at this, let's just set z, no, let's not set z equal to 0, let's set y equal to 0. And if we just do that, we get like that. Actually, let me just draw it a little bit better. Then we have y like this. Set x equal to 0, we get this. And we get circles around and around and around, because these are all circles right here, right? This is the standard form in which you would write a circle. And then for x equals y squared plus z squared, it's the same idea, except you're extending it out into a different dimension. In this case, we have to think of y and z as our parabolas. So now we have x squared. We can just set z equal to 0 for this one, where it's going to be a parabola like this. And then x equals, and we can set y equal to 0. Y equal to 0, which would make it be z squared equals x. And that would look like x equals z squared. Let's see what that would look like. So that would be, and then you would draw these circles around it. And then that would also be these circles right here, because this is also another way of drawing the circle right here. And generalizing it, we have quadric surfaces, which is kind of like conic sections, but like an extension of that idea into 3D. where we have this whole cluster right here, but all these other components are just constants. I mean, not constants, but like it would just be centered at a different point. Usually it's gonna be centered at the origin, which is gonna be 0, 0, 0. And with that, we have rotations and translations. These possibilities can be reduced to two different types. So something like this, where j can be positive or negative here. You can flip the equation. A, B, and C may be positive or negative. And then this, where A, B, and I are all constants. However, Z may not always be the one without it being squared. It may also be an X or a Y, so it really depends. And with this, we have ellipsoids. This is kind of similar to a normal ellipse in 2 dimensions, right? Extending it outwards. And you can see these traces in the X, Y, and Z. You can see right here, this is going to be a YZ trace right here, an XY trace across here, and then a XZ trace right here. A hyperboloid of one sheet. If you set like y equal to 0, for example, you would get the hyperbola looking like this. If you set x equal to 0, you would get the hyperbola looking like this. And then if you set z equal to some constant or whatever, you would get these circles pointing outward. The hyperbola had 2 sheets, breaks off into its own separate thing. So you're gonna get 2 hyperbolas regardless of the case. And there's gonna be a lot of dead area in the middle. Elliptic paraboloids, that's actually the example we did above. Or it's like a variation of it, right? And then we have a hyperbolic paraboloid like this. And these are all the different traces of it, right? Elliptic cones. You see the circles right here. And then you can see the lines as well. And yeah, that's pretty much it covering over quadric surfaces. And to name and sketch these graphs, we can try the more complex ones if we so choose. So this right here is going to be a hyperboloid of 2 sheets. And we're going to solve for it equal to 1, 9 over negative 4 x squared minus y squared over 4 plus z squared over 4 equal to 1. And this is going to look kind of sketchy to graph out, but as long as you know what you're doing, it shouldn't be that bad. And since we are going to be working in the z-plane, since we're going to be working like this, let's just extend everything out. First off, let's set z equal to 0. Yeah, z equal to 0 might be a good start. Yeah. So then we get a hyperbola that looks something like that and something like that. And then the ellipses are formed in the XY plane where it's going to look something like this, and something like this, and then the YZ is going to look something like this and something like this. Let me just draw that down here. And then you have it rolling down like this as the hyperbola as well. And this will extend on and on downward. This one, example B, is a hyperboloid of one sheet. And this will be a lot more manageable to draw. So again, let's just get everything down to its easier components. It's going to be 9/4x² plus y² over 4 minus z² over 4 equals 1. And then let's just set z equal to 0 first off. This is just going to get us an ellipse from the origin to the top. Let me just make this a little bit more accurate to scale. There you go. We can just have a couple lying around. And then we have the hyperbola going like this in the XZ plane. And then in the YZ plane, it'll go like this, and it'll go like this. And you draw more of these out. And you can get the general sketch of it as it goes along downward. And it goes down to the negative, extends wider and wider. And although these aren't perfect sketches, this is like a generalization of what the graphs would look like. This is going to be this graph right here is going to be an elliptic paraboloid. So we can try this one real quick. It's just going to be a series of parabolas going up. And I think the one in the y direction is going to be a lot more steep. So we can draw this one a little bit fatter. This one's going to be going up a lot more steep. And then you have your ellipses. Have your ellipses or ellipsi being drawn like this. It's going down and so on and so forth. And again, these are kind of on the fly sketches, but this is like the general idea of what these graphs would look like. And these ones right here are pretty easy to draw, and these are all cylinders, which we've covered in our previous video. That's pretty much it. Thank you for watching, and I hope you guys have a fantastic day.